In this video, I will show you how to solve a system of conic sections like this one. Now, let's see, what do we have here? The top equation is an ellipse. I can tell because these denominators are different numbers. The top equation is a circle. There's no denominator showing, but if I were to divide this by 25, say, okay, to put it in the same form as the top one, the denominators would be 25 and 25. So when those numbers are the same, it's a circle. If the numbers are different, it's an ellipse. So we have a circle and an ellipse. So solving a system involving a circle and an ellipse might look something like this. So there's an ellipse and here's a circle. So there could be 4 intersection points. Okay, now there could be fewer depending on where this circle is in relation to the ellipse. There could be no solution if I have an ellipse and then a circle and they're not touching at all. So, but that's the idea. We're going to try to find the intersection points if any exist. We're going to go ahead and do substitution, which works nicely on a problem where you have part of it that's the same. See how I have this x plus 2 squared, and then down here I have x plus 2 squared again? That's when it's a great time to do substitution. Because what I can do is I can rearrange this problem to get the x plus 2 squared by itself very easily. I can just subtract y squared from both sides. So then that's going to give me x plus 2 squared is equal to 25 minus y squared. Alright, so now what I can do, it's going to draw a line right here. I can write the other equation, but instead of putting x plus 2 squared, I can put what I have on the right hand side of the equation. So that's what I'm going to do now. I'm going to take this equation and rewrite it. So right away I'm going to have this. Okay, so instead of x plus 2 squared, I'm going to have 25 minus y squared. Alright, because these are equal, I can substitute. Alright, so that's over 9 plus y plus 1 squared over 16 is equal to 1. Now this equation has only y's in it, so I should be able to solve for y if I'm very careful. First I need to add these two fractions together. In order to do that, I need like denominators. So I'm going to multiply this fraction by 16 over 16, and I'm going to multiply this fraction by 9 over 9. So what I'm going to end up with then is, alright, I guess I'll go ahead and distribute. So let's see. Alright, I've got this. 16 times 25 is 400. 16 times 9 is 144. Can't distribute this because it's squared, so I just definitely have to leave this as 9 times y plus 1 squared over 144 is equal to 1. Now I've got like denominators, so I can put all this stuff together over one giant denominator. Okay, so now I've got 400 minus 16y squared plus 9 times y plus 1 squared. I don't like the fact that this is a fraction, so I am going to multiply both sides by 144. Maybe I should use brackets. So if I multiply by 144 on both sides, then this 144 and this 144 will cancel each other out. So now I have no more fractions, so I just have 400 minus 16y squared plus 9 times, I'm going to have to deal with this eventually, so I might as well start working on it now. Y plus 1 times y plus 1 because it was squared, and now it will be equal to 144. Okay. I'm going to multiply these two together. So I'm going to get y squared, 1y, another 1y. I'm combining like terms. I get 2y plus 1. Okay, now I'm going to distribute this 9. So I'm just going to copy all this down. But distributing the 9, we have 9y squared plus 18y plus 9 is equal to 144. Whew! Okay, got to combine some like terms here. So negative 16 plus 9. Okay, then I've got plus 18y and 409. Putting these together is equal to 144. Let's subtract 144 from both sides. So you're going to end up with this. I do not like the fact that this is a negative leading coefficient, so I'm just going to divide everything by -1 real quick. So then I will have 7y squared minus 18y minus 265 is equal to 0. Now this may be factorable, but with numbers this big, I would rather just use the quadratic formula. So that's what I'm going to do. So A is 7, B is negative 18, and C is negative 265. So I'm just going to use the quadratic formula over here. I've got loads of space, so I might as well use it to my advantage. So the quadratic formula, hopefully you will recall, well, I should say y, because we're solving for y right now. Come on, eraser, let's go. Okay, so y should equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, the part underneath the radical is called the discriminant. Boom. Always do that part first and separate from the rest of the problem. So I'm going to do the discriminant right now. I will call it D for discriminant. So what was B and stuff again? So we have negative 18. I'm not going to ever remember that. So I'm doing b squared minus 4ac. So I've got negative 18 squared minus 4ac. So a and c are 7 and negative 265. That's not enough space. Okay, I'm going to calculate this off camera. I trust that you have the ability to do this. I got 7,744. So that's the thing under the radical. Now let's go ahead and set up the rest of it. So back to the quadratic formula. Y should equal the opposite of b. So b was negative 18. So the opposite of b will be positive 18. Plus or minus the square root, and then the discriminant goes here. So that's your 7,744 that we just found. All over 2a. Well, a was 7, so 2a is going to be 14. Now, it turns out that the square root of this number is 88. So I'll have 18 plus or minus 88 over 14. Okay, so the plus or minus means that we have 18 plus 88 over 14, or 18 minus 88 over 14. So this comes out to be 53 over 7 or -5. I have a feeling we're going to just need a decimal for this at this point, because we're going to have to substitute this back into a fairly complex expression, and I think we're just going to go to a decimal now. So that's 7 point, I'm rounding to the nearest thousandth, so 7.571 or -5. Understand that this is what we have so far. We found these two y values, but we still need the x values to go with them. So we're going to take these y values, plug them back into one of the original equations, and see what we get for the x values. Okay, so I think I still have some space over here. So I'm going to change colors as I do this. So for now, let's go ahead and let y equal, don't crash. Let's let y equal our first value of 7.571. So I'm going to take this expression, I'm going to substitute this value in for y and see what I get for x. So I'm going to have x plus 2 squared is equal to 25 minus 7.571 squared. Okay, let's see, what is that? So 7.571 squared is 57.320. So I've got x plus 2 squared is equal to 25 minus 57.32. That's giving me negative 32.32. Well, that's no good because I have something squared equaling a negative number. That can't happen. So there's going to be no solution here. Okay, another way to look at this is if I kept going, my next step would be to take the square root of both sides. And you can't take the square root of a negative number. You're just going to get imaginary numbers. So I'm going to get no solutions from this guy. That doesn't mean I have no solution. I still have another y value to use. Okay, but that's telling me that the y value that we just did right now did not work out. So that's gone. So let's see what happens if we let y equal -5. Alright, let's see what happens then. We're still using that same equation, x plus 2 squared equals 25 minus y squared. But this time y will be -5. So that's x plus 2 squared is equal to 25 minus -5 squared. Something fishy is about to happen. -5 squared is 25, and 25 minus 25 is 0. This is solvable. The next thing I would do would be to take the square root of both sides. My computer's running really slow, so whenever I try to switch colors, it takes forever. Normally I would do a plus or minus right here, but since it's just 0, that would be silly. So I'm not going to do that. I might have to stop switching colors back and forth. It makes it more clear, but it takes so long to switch colors that I don't think it's worth it. So x plus 2 is equal to 0. subtracting 2 from both sides, I'm going to have x equals -2. Alright, so I had a y value of -5, and I got the x value of -2. So I'm just going to take that -2, put it back up into the thing. Here I am waiting for the color to change, which I said I wasn't going to do. So this is it. It looks like we only got one solution out of this thing. So it's going to be interesting to see on Desmos.com how this looks so that we got this one solution. Okay, so let's remember what we had. Oh yeah, we had a circle and an ellipse, and here we've got one solution. So it'll be really fun to see what this looks like on Desmos. How neat is this, y'all? So the circle, you can see we have our red circle here, and our ellipse is this lavender color right here, and you can see that they are touching just at one point, and the point is -2, -5, which is what we found by the magic of mathematics. Isn't that nice? Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.